Quantitative Data Analysis Techniques, Assignment 4.5.1, Mark Keneally. Range. The range, so according to Adams, range is the difference in numerical value from the highest to the lowest values collected. In order to calculate the range, you need to subtract the lowest value from the highest value. The table above shows scores collected from a flying sprint test, which was being measured in seconds. The range for the flying sprint test would be 0.7, as the highest value is 2.616 and the lowest value is 1.46. This is because if you subtract 1.46 from 2.16, it would give you 0.7, which would be the range. Rank order distribution has been used on the table showing triceps skin fold caliper test results. According to Adams, rank order distribution means placing your data into an ordered list from lowest to highest in a single column, ensuring you include all the scores. The only time rank order distribution would be used when the number of participants is less than or equal to 20. So the rank order distribution of the triceps skin fold caliper test shows that the lowest score achieved was 3 and the highest was 13. And the amount of values were less than or equal to 20. So according to Bridgens, a frequency distribution table is a chart that summarizes values and their frequency. It's a useful way to organize data if you have a list of numbers that represent the frequency of a certain outcome in the sample. It has two columns. In one column, it displays all the individual values and raw data scores, whereas in the other column, it shows the frequency that this value occurred. For example, if the values from the biceps skin fold caliper were put into a simple frequency distribution graph, then it would look something like this. So it starts off not in the right order, then it's ordered, and the frequency shows how many times each value appears. Grouped frequency distribution is similar to simple frequency distribution graphs, as they are made up of two columns, and in one column it displays the frequency. However, in the other column it shows grouped values. L. Ali from Sciencing.com says the grouped frequency table is a statistic method to organize and simplify a large set of data into smaller groups. When the data consists of hundreds of values, it is preferred to group them in smaller chunks. This makes it more understandable. An example of grouped frequency distribution would be the sit and reach test results, as they were in order that the research conducted them. However, they have been rearranged so that it's easier for the researcher to see how many performers achieved a score in each category. Therefore, all scores between 21 to 30 are put into one category, and this is continued throughout the data until all the readings were in categories which the researcher can read easily. So there's 0 values from 1 to 10, there's 0 values from 11 to 20, there's 6 between 21 and 30, 4 between 31 and 40, 3 between 41 and 50, and 1 value in between 51 and 60. 4.5.2. So this is a scatter graph. It can be used in a situation to show the results of the tricep and bicep skin fold caliper test. It shows the relationship between the two sets of results, as it shows the same performers tricep and bicep skin fold caliper, meaning if everyone got a high bicep skin fold caliper and then got a low tricep skin fold caliper, then the trend would appear if everyone got the same. So this is the line of best fit. So this is the correlation. So it's positive because it's going up from left to right, and the values are increasing. So this is a cluster chart, and it shows the same participants' results in two different tests. So in this one, it shows the systolic and diastolic blood pressure of participants. This would make it easier for the researcher to be able to see who achieved the highest and the lowest in both tests, and whether the scores fluctuated or were consistent. So you can easily see that number 8, number 4 had the highest test for systolic, and it looks like number 5 has the lowest for systolic. Looks like number 7 had the highest for diastolic, and it looks like number 13 had the lowest for diastolic. So this is a line chart, and this shows two different sets of data, two sets of results for the same performer in two different tests, and it compares them. So in this situation, it shows the results of a static sprint test, which is the blue line, and a flying sprint test, which is the red line. So this would allow the researcher to be able to see who achieved the highest scores in both tests. So you can see that the highest score overall was number 11. And this would also be able to see if there were any outliers, which I believe number 11 probably is, considering everyone else is quite similar in results apart from one reading. So this is a table. It's an easy way to show data. It can be used to show the maximum and minimum values very easily, as well as any outliers, as the score would stand out from the other results. Don't think there are any here that I can see. Their score would stand out because they would be so much bigger. So if there was an outlier here, let's say F was the outlier, that could be 256, and that would be an outlier because it was so much bigger than everything, all the other results. The data is ordered so it can be read easily, and the researcher can see who achieved the best and worst scores in each test, as well as identify which participant it is, as it says who they are in all three of the tests. So this is a box and whisker graph that shows the vertical jump scores of a performer. Using this, we are able to see the maximum and minimum values. So this is the maximum value that they achieved. This is the minimum one. We can see the mean score, median score, so that's this line here. We're able to see the range in the scores, so that's obviously from the maximum to the minimum. We can see the interquartile range, that is from here to here. So we can see whether it's consistent or not. Now, the results look fairly consistent. However, there is a big lower quartile. Now we may be able to see some outliers if they are the medium and maximum value. For example, if this looks exactly the same, apart from this value is all the way down here, then that could be an outlier, or if this one is up to 500, but all the other results are at 50 to 20 or even 15. So this is a histogram. It shows the frequency that the participants reach a certain score. For example, this histogram is showing the results of a system reach test, and shows that 9 performers were able to achieve a score between 22 and 36 centimeters. 4 performers were able to achieve a score between 36 and 50 centimeters, and 1 performer achieved a score between 50 and 64 centimeters. So this is a normal distribution curve. So the normal distribution of data means that most of the examples in the set of data are close to the average or the mean. So the mean is this line here, and most of them are close to the mean. The graphs are bell-shaped, and the mean of the data would be in the center, which is the data would also be symmetrical around the mean. So both this side and this side would be the same. In between this line here and this line here would be 68.3% of the values either side of the mean. Between this line and this line, 95.4% of the values are between, so this is -2, this is +2, standard deviation either side, and between +3 and -3, standard deviation, 99.7% of the results are included. So if the data is asymmetrical, so this is the normal distribution curve, but it can either be positively or negatively skewed. If it is negatively skewed, then the longer tail would point towards the negative direction of the graph, and the scores would be bunched together on the right side of the mean. So the mean would be here, and they are bunched together on the right hand side. If it is positively skewed, then the opposite would happen. So the longer tail would be going negative direction, means here, and they're all bunched together on the left hand side. So Winsorizing is a method used to help deal with outliers and outstanding statistics which could possibly ruin data and influence the mean and other scores. So this is where the researcher changes the outlier for the highest score or the lowest score, depending whether it was an outlier because it was really low or really high. This way there's the same amount of values, but the outlier just becomes more accepted and can be used in means and other results without negatively affecting the data. So as you can see, there was one all the way as a value up on 35 when the next highest was at about 17, 18, 16 even. It is then changed to copy it, and so that there are two values which are high. Trimming is the other method used to deal with outliers in data. The process involves the researcher getting rid of the outlier completely so that the data has one less value. However, this would allow them to still gain the mean of the other students which were previously influenced by the outlier. The researcher would not include the outlier at all in any of their work in any data, as it would influence or change the outcome. So there is one here.